Welcome back. So today we're going to be identifying missing parts of similar figures. Now that we know that similar figures have angles that are the same and sides that are proportional, angles are the same and sides are proportional. Okay, so I recorded this video and I've already written the notes down, but apparently only 10 seconds of it saved. So I am back later this afternoon now to record it again. Here's our learning target. Again, expectations, remember to use twice this video's length. It will be a little different because they're already pre-written. I'll show you them, but then I will then explain them piece by piece. So just know that you're not going to see me writing anything. And then here's the after the video that I will come back to at the end. So table of contents. Again, I've already recorded this. So we are on missing parts, and that should be page 8. So again, we're on missing parts, page 8. So we're going to skip ahead, page 8. All right. So as an overview, you're going to be seeing that a reminder that angles are the same and sides are proportional, our title, and then here's our learning target. So pause the video and write down everything you see. So angles are the same and sides are proportional. That means the figures are similar. Missing parts is our title. We're on page 8. Learning target, I can identify missing parts of similar figures. The rest of the notes are 6 examples. So take your piece of paper, draw a line down the whole middle, and then draw 2 lines, and you're going to get 6 examples. Yes, I'm doing that fast. Yes, I don't want you to copy. Okay, so we're going to do one example at a time. So I'm going to try to make this, actually, I'm going to move my desk down to zoom in. Oh, come on. There we go. All right. All right. So, example 1. All right, this is example 1, and I'm going to talk you through it. So on example 1, we're drawing 2 different triangles. We know these triangles are similar. Every single thing you see today, we know the 2 figures are similar to each other. So we know that the angles will be the same. We know the sides will be proportional. Notice that we have letters. So on the side, the corners, the vertices, so I guess I will write a word. So corners of our figures are called vertices, is the plural. Each one is a vertex. So repeat after me, vertex, vertices. Okay, so W, U, and X are all vertices. Z is a vertex. Y is a vertex. X is a vertex. And we write vertices with only capital letters. So this is a capital X. This is a lowercase x from representing our missing side. So I put a question mark on it just so you can tell that this is a vertex. This is our unknown value, the missing part that we're trying to find. So on this first triangle, we have 2 sides labeled. We have 20 meters labeled, which corresponds to the 4 meters. And we have an X, we don't know what it is, and that corresponds to the 7 meters. So we can look at this as we've done before in the past, and we can see that 4 times 5 gets us its corresponding side of 20, and 7 times 5 would then get us 35 meters. I know I can multiply 7 by 5 because I know these are all similar. And if they're similar, they have a scale factor. In this case, the scale factor is 5, going from the small to the big triangle. 7 times 5 is 35. I stick on the meters, I include the variable I'm looking for. So I include the x equals and I include the meters. That's example 1. All right, example 2. Again, I'm drawing 2 figures. I want you to figure out and look at that scale factor of how it's working. So I can divide 8 by 4, or blah, blah, blah. I can divide 8 by 2 and get 4. Or I could have multiplied 8 by a half and gotten 4. Or I can do 4 times 2 and I get 8. So there are 3 different ways, and all 3 ways work to see the patterns. So as you're copying this, or as you've paused and you're coming back and listening to this, make sure you're recognizing that you can divide by 2, you can multiply by 2, and you can divide by a half, and you can multiply by a half. Just think about those processes, and all 4 of those actually work depending the direction you're going. Knowing that 2 times 2 gets us our unknown value of 4. There aren't any units on this example, so my answer is just 4. All right, next 2 examples. Here's 3. Now this is a lot because we're introducing a new strategy. So on 3, 4, 5, and 6, we're going to be setting up a proportion. You've been using proportional reasoning and drawing these arrows for scale factors on all of our figures. We're going to do it without arrows this time on the figures, and instead translate the figures and their measurements into a proportion, which you've solved before, and then using the arrows between those to figure out our scale factors in the missing number. Okay, so notice that I have the circles. So x and 3 inches, they both correspond. They're both corresponding sides on our similar figures. 12 and 5 also correspond on our similar figures. So repeat after me. X and 3 inches correspond. X and 3 inches correspond. 12 inches and 5 inches correspond. 12 inches and 5 inches correspond. Now, that gets me 2 of the fractions or the 2 ratios, but I also want to compare x and 12 inches. Why? Because they're in the same figure, and fig here represents figure. Fig represents figure. So x and 12 inches are in the same figure. Repeat after me. X and 12 inches are in the same figure. 3 inches and 5 inches are in the same figure. 3 inches and 5 inches are in the same figure. That's how I know to set up my proportion. I have a correspond, correspond, same figure, same figure. Correspond, correspond, same figure, same figure. Now, you can rearrange these as necessary. Sometimes there's more than one way to set it up. Totally fine. But x will never be compared to 5 inches because they have nothing in common. They don't correspond, and they are not in the same figure. Same reasons why 3 inches and 12 inches will never be in a line horizontally or in a line vertically because they do not correspond to each other and they are not in the same figure. So watch out. You have correspond, correspond, same figure, same figure. All right? Looking at that, we set it up, and then I use my calculator, and I'll put my calculator back up again, and we'll do this. So I did 12 divided by 5. And I got 2.4. So that means 5 multiplied by 2.4 gets me 12. So that's my scale factor. So then I do 3 times 2.4, so times 3, and I get 7 and 2/10. Okay? So 7 and 2/10 inches. They gave me inches, so I better have inches on my final answer. Make sure you have those units. All right, I'll close the calculator down. Example 4. So here we're drawing 2 triangles. Remember, every single pair of shapes you're seeing in this lesson are similar. So we know these 2 triangles are similar. They're just measured differently. They have different measurements. So this one has x, which corresponds to 18 meters. 9 meters corresponds to 4 meters. So look at my proportion. 9 meters, 4 meters. They both correspond, which then leaves me to x and 18 meters, correspond. You should not have x meters over x because 9 and 18 meters, do they have anything in common? Do they correspond with each other? Does 9 meters correspond with 18? No. Shake your head no. 9 meters does not correspond with 18 meters. Are they in the same figure? No. Shake your head no. Go along with me in the video. Shake your head no. Okay? So that means 9 and 18 should never be in a line with each other. Instead, 9 meters is compared with x because they are in the same figure. 4 meters and 18 meters are in a line because they're in the same figure. So make sure you have correspond. Same figure. Knowing that, I'm going to use my calculator again, and this time I'm going to be doing 9 divided by 4. So when I do 9 divided by 4, I end up with 2 1/4. 2 1/4 is also the same as 2.25 as a decimal. That tells me 4 multiplied by 2 1/4 equals 9. So 18 multiplied by 2 1/4 gets us our answer of 40.5 meters. Stick that meters on there, stick the x equals, because that's the variable they gave us. If they gave us a different letter here, I would put a different letter here. Okay, and our last two. There we go. Example 5. So you're drawing those 2 rectangles. I want you to try to set up the proportion on your own. Yes, you may have just seen a glimpse of it, but pause the video here. Can you set up a proportion that has a corresponds, same figure, same figure? So you should have an 8 meters with a 26 meters as one of your fractions, or 26 over 8, okay? And then 4 meters over y. If you did 26 over 8, you should have y over 4m. If you flip them, both should be flipped, all right? These should be corresponding. Same figure, same figure. If you have an 8m and a y, you did something interesting. If you have 4 and 26, you did something interesting. Fix it, all right? Knowing that, use your calculators, figure out what is the scale factor going from 8 to 26. Another way to actually do it, I just saw this now, is going from 8 to 4 is dividing by 2 or multiplying by a half. So then what's 26 divided by 2? And that gets you the 13 meters. Wow! Second time doing it. There's more than one way to do it. All right? Pick the way that works or the quickest way you can see at the time. All right. Last example. These are tables. So they have little legs behind them. So you have 4 legs on each of our tables. The tables are rectangular. So I have a 24-inch dimension, an X inches. I don't know how long it is. And then I have a 36-inch dimension and a 54-inch dimension. Knowing that, can you make a proportion that corresponds, same figure, same figure? Pause the video. You should have an X and 54 being compared, 24 and 36 being compared, and you should have X and 24 being compared, and 54 and 36 being compared. There's more than one way to write the proportion, but you should never have X and 36 being compared, or 24 and 54 being compared, because they are not in the same figure, and neither of them corresponds with the other. When I solved this, I simplified the 24 over 36. I divided them both by 12, so I ended up with 2/3. And then I did long division, and I figured out 54 divided by 3, it would be 18. So then 2 times 18 gets us 36 inches because I have my units. So there's that. And my video is probably about the same length as the first one, actually. This didn't save much time, did it? Okay, well, hopefully at least makes you write faster. And now you don't have to wait for me to write it. So give me feedback if this was better or worse. And after the video, did you focus and go somewhere without many distractions? Did you pause the video? And how many times did you do it? Did it help you? Did you pause less with this format, or did you pause more with this format? Please let me know, and I'd love the feedback. All right, so have a great day. Bye.